This is a quadratic functions exam review. So in this video, we're going to just go over some questions or exam type questions that you may see on an exam for quadratic functions. Some of the topics that are going to be covered when we're reviewing these questions are solving quadratic functions by completing the square, factoring, quadratic formula, finding a number of solutions using the discriminant, key features of standard factor and vertex form, converting from standard to vertex form, comparing forms of quadratic functions, so looking at graphs and charts, and also transformations of quadratic functions. So let's go ahead and get started. The first question we're looking at, it says, if the quadratic equation x squared plus 6x minus 55 equals 0 is written in the form x minus p squared equals q, what is the value of q? And so this equation is in vertex form, and so we're given an equation in standard form, so we want to convert this equation from standard to vertex form to find q. All right, so I'm going to just rewrite this equation here. Well, instead of rewriting the whole thing, I'm adding 55 to both sides. And so since this is a minus 55, when I move it to the other side, I add it to the other side, it becomes positive. And so completing the square. And so x squared plus 6x, I take half of 6 and raise it to the second power. Half of 6 is 3, and 3 squared is 9. So I'm going to add 9 to both sides. And then I want to factor the right-hand side. This is a perfect square trinomial. Take the square root of x squared, which is just x. Remember to take half the exponent. And the square root of your c. So square root of 9 is 3. Whatever sign you have here, that's first. That's what you're going to put. Squared. All right. Simplifying my right-hand side, 55 plus 9 is 64. And we notice that we have it in the form that we want. And we're asked to find a q. And in this case, q would be 64. So what is q? Q equals 64. Let's take a look at number 2. Solve the quadratic equation by completing the square. And so same process here. So x squared minus 4x equals 5 because I added 5 to both sides. So same thing I did here. Added 55. I'm going to add c to the other side. Inverse operation, since that is a minus, I added. Completing the square, creating a perfect square trinomial. Half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. Pen here. 5 plus 4. Perfect square trinomial, factoring. X minus 2 squared equals 9. To solve, I want to get rid of this 2, so I'm going to take the square root of both sides. I'm left with x minus 2 equals, the square root of 9 is plus and minus 3. So from this point, I could separate it into two one-step equations, or I could go ahead and solve for x and then simplify those numerical expressions. So I'm actually going to solve for x. If I add 2 to both sides, I'm left with x equals 2 plus or minus 3. So x equals 2 plus 3, which is 5, and x equals 2 minus 3, which is negative 1. So my solutions are 5 and negative 1. Next, number 3, it says, state if the following equations have no real solution, one real solution, or two real solutions. And so on a test, you would not be given this formula right here. You would have to know that, okay, if they want me to find the amount of solutions, I need to use a discriminant. And remember, the discriminant is the piece that is under the radical of the quadratic formula. So if you think, okay, this is under the radical of a quadratic formula, to get no real solution, I would have to get a negative, because you can't take the square root of a negative number to get a real number, or to get a real number. One real solution if you get 0 under your radical, and two real solutions if you get a positive. So I'm actually going to write my answers at the bottom because I'm going to have work all over this page. So the first one, I actually not going to, the first two, because I could kind of solve these right here. For A, if I just take the square root, my answer is going to be x equals plus or minus 5. That is shorter than finding a discriminant. So that is two solutions. So if you see that you can solve it quicker than finding a discriminant, do that. And the same thing for the second one here. X squared minus 89 equals 0. If you're adding 89 to both sides, right? X squared equals positive 89. You're going to end up taking the square root of a positive number. So you're going to get two solutions. So for those, because I could work them out quicker than I could use a discriminant, I just simply worked them out. All right. But for C, let's take a look at C. X squared minus 4x plus 4 equals 0. So let's label it. A is 1, B is 4, C is 4. And just plug it in. That would be negative 4 minus 4 times 1 times 4. Plugging it into my discriminant. And that would be squared here. So negative 16, 4 squared is 16. 4 times 1 times 4 is 16. So I get 0, which would give me 1 real solution. And if I look at the next one here for D, rewriting it, 2x squared minus 3x, and I'm back up here. So since I don't have, everything is not on one side of the equal sign, I want to move it to the other side. So since that is a positive 40, I'm subtracting 40. So my 40 becomes negative. So remember, finding the discriminant, everything has to be on one side, set equal to 0. Just like if we were solving using a quadratic formula. All right, so plugging that in, negative 3 squared minus 4 times 2 times negative 40. Negative 3 squared is 9 minus 4 times 2 times negative 40 is 320. And I get, this is going to be plus because I have a minus and a minus. So that gives me 329, which is positive. So that is two real solutions. And last, discriminant, 3x squared plus 27 equals 0. I have an A and I have a C, no B term. So B is 0. So that would be 0 squared minus 4 times 3 times 27. 0 squared is 0. 4 times 3 times 27. Or negative 4 times 3 times 27 is negative 324. 0 minus 324 is a negative. So my discriminant is negative. So that gives me 0 real solutions. Or no, I could say no real solution. All right, so let us move on. Number 4, it says, what is the solution of the equation? And so we could solve this by factoring, or we could solve this using the quadratic formula. I'm actually going to review different methods here, so you can see I have the quadratic formula here. So A, B, and C. So let's just plug it in. Negative B, so that'll be, or that will be, negative times a negative. So make sure I put that double negative. Plus or minus B squared, so negative 6 squared minus 4 times A, which is 4 times C, which is 2, all over 2A. A is 4. Simplifying this, that should be X. X is equal to 6 because that negative canceled out. Plus or minus 6 squared is 36. Negative 4 times 2, so that would be negative 16 times 2 is 32. So minus 32 all over 2 times 4, which is 8. X equals 6 plus or minus 36 minus 32 is, of course, 4 all over 8. That is 6. The square root of 4 is 2 all over 8. So I could separate it. Well, actually, now I'm going to separate it. So I have 6 plus 2 over 8 and 6 minus 2 over 8. So 6 plus 2 is 8, and 8 over 8 is equal to, I'm going to put it here, 1. So x equals 1. And 6 minus 2 is 4. 4 divided 4 over 8, so that just reduces to 1/2. So my solutions are x is equal to 1 and 1/2. I'm going to show you another way to solve this. I'm going to actually factor it. So if I factor it using the AC method, I multiply a and c. So 4 times 2 is 8. I find two factors of 8 that have a sum of -6, and those factors are 4 and 2. So what I did, 4 times 2 is 8. Factors of 8 that have a sum of -6 are -4 and -2. I'm going to replace that -4 and -2 for the -6x. So 4x squared minus 4x minus 2x plus 2. So as you can see, I replaced it here. And then I factor by grouping. Group out the first and second set of terms here. I could factor out a 4x. I'm left with x minus 1. The second one, I could factor out a -2. I'm left with x minus 1. And again, my outside terms are 4x and -2, so that's 4x minus 2. And I could have actually factored out a 2 first, but since we're solving, I just, you don't necessarily have to, because you're going to just end up reducing your answers anyway. And so if I set these two equal to 0, right, add 2, just a two-step equation, divide by 4, x is equal to 1/2, add 1, x is equal to 1. So we knew that, but I'm just showing you a different way to solve it. And so hopefully I gave myself enough space here. I'm actually going to erase what I have. Well, I like to fit everything in, so let me try and see. Let me just erase a little bit. I'm going to erase this 0, so we know that. Okay. And move over this x equals 1. So, trying to fit it in here. So, I'm going to actually factor using another method called the slip and slide method. So, I can slip my 4 over to 2 by multiplying. 4 times 2 is 8. And I can rewrite this expression as x squared minus 6x plus 8. And most of my students actually prefer this method. They find it a lot easier. I'll just go ahead and add my 0. And then I want to factor. So two factors of 8 that have a sum of -6. And we already found that they were -4 and 2. So x minus 4 and x minus 2. And whatever I slid over, I divide that by my factors. So I slid over to 4. So that 4 is what I want to divide by. All right, so I divided my factors by 4. I reduce. 4 over 4 reduces to 1. And I could bring up this 4 and do 4x minus 2, or I could go ahead and just reduce. I'm going to show you what happens if we reduce. You're going to get the same thing. All right, so x minus 1, if I move up this 2, 2x, so I have to slip up this 2. And I get my same binomials, or similar binomials. I just reduce first. And what do we know? Same answer. So my students are probably like, why didn't you, or would be like, why didn't you just do this in the first place? But I like to show different methods. So of course you don't have to do all 3 methods on a test, but I just wanted to, since this is a review, I want to show you how to solve using different methods. All right, so let us move on to number 5. All right, let's take a look at number 5. It says the following equation has been rewritten in 3 different ways. If this equation is for the profits a company makes and X represents the prices, explain what each form represents. So standard form, we're going to just look at the key features of each form. So for standard form, the key feature is that y-intercept or the initial value. So our initial value or our y-intercept is always c, which is 4. So 4 is the initial value. The factored form gives us our zeros. And so if you were to solve this, x plus 1 equals 0, we subtract 1, x equals -1. X plus 2 equals 0, subtract 2, x equals -2. And so we could say that 1 and -2 are the prices. And vertex form gives us our vertex here. And this is vertex form. So just so you can see it here. And our vertex is h and k right here. And this gives us our max value, which is our y value here, since our vertex is 3, 2, or -3, 2. It's going to be the opposite. And -1/4. 1/4 is the maximum value. Number 6, it says Mr. Tavares kicked a soccer ball up in the air. The function ht is the height of the ball after t seconds. H of t equals -16 t squared plus 1 plus 80t. So part A asks, after how many seconds will the ball hit the ground? So of course on a test you won't have these hints here in red. This is for the review. So after how many seconds will the ball hit the ground, we want to find the domain or the zeros. And so if you think about if a ball is thrown, it's going to arc up and come down. And so we want to find what happens here. That is our time when the ball hit the ground. So if this is the x-axis, because it is horizontal, right, these would be our zeros. And so we can solve this by just factoring. We only have 2 terms, so I could just factor out a GCF. So greatest common factor is -16. T. I divide, I get t minus 5 equals 0. Say each one equal to 0. -16, t equals 0. Divide by -16. T is, of course, 0. And then t minus 5 equals 0. So add 5. T equals 5, which is the one we want. And so it would be here, 5 seconds. That's our answer. B, after how many seconds will the ball reach the maximum height? So maximum height, we think vertex. And so we want to rewrite this equation in vertex form. So -16 t squared plus 80t. I don't have a c, so I don't have anything to move over. I'm going to factor out this -16 so I can complete the square. So t squared, I'm dividing now. So 80t divided by 16 is -5t. So to complete the square, I take half of 5, which is 2.5. And 2.5 raised to the second power, all right, it's going to be, I want to put it in decimal form. So that's going to be 6.25 equals, so I have to write something equivalent on the other side. So instead of adding 6.25 to the other side, I need to write the equivalent of what I have here. And so this 6.25 is really being multiplied by this -16. I need to multiply the two. So -16 times 6.25 is -100. So now factor -16, bring that down. Square root of t squared is t. I have a minus sign, so that's minus. The square root of 6.25 is 2.5. All right, just using my vertex form here. Equals -100. And I want to move that negative 100 over, so I'm adding it to both sides. Right, so the negative 100 becomes positive. So plus 100. So this is not my answer. I just want the y value of my vertex here. So I'm trying to circle it. So my vertex is 2.5, 100. And I only want the y value because that's my height, my vertical unit here. So that would be 100. So my maximum height is 100. Does it give us units? I want to say feet. 100 feet. All right, maximum height is 100. Number 7, it says Hugo has a pool service company. His business charges a flat fee for supplies, and then depending on how big the pool is in square feet. The length of a certain pool is 5 feet more than the width. So, and the company charges in dollars for cleaning the pool 6.5x times x plus 5 plus 50. And so if we look at this problem here, it says the length is 5 more feet than the width. And so this will represent our length, and this piece will have to represent our width. So part A, it says, what does the 6.5 represent? So we're multiplying 6.5 times. We could say this is the area of the pool because that's the length times the width, or width times the length. So that 6.5 represents the price of each foot because we're looking at how much the company would charge. What does x times x plus 5 represent? And so we've kind of gone into that. That would be the area because the x plus 5 is L. The x would be W, and x times x plus 5, so width times length, would give us the area. So that's the area of the pool. And 50 is the constant, and so that 50 will represent the flat rate, that value that does not change, that they would charge for the pool before they even calculate the area and the price per square foot. Now we're taking a look at number 8, comparing quadratic functions. And so we're given two types of functions here. We have an equation and a graph. So f of x is our equation, g of x is the graph. So part A, it says the maximum value of f of x is blank the maximum value of g of x. So we're looking for if it is smaller or larger. So our maximum value here for g of x is, our vertex is 2, 3, so our maximum value is 3 for this one, because we could just look at it and see the vertex. So what do you think we have to do for our equation? We're not given a graph, so we have to find a vertex. So of course, we have to write it in vertex form. So this form here. All right, so let's rewrite it here. So x squared, or negative x squared, minus 4x. If I replace this with 0, I'm kind of flipping it. I'm moving this 2 over. So since that is a plus 2, I'm adding 2 to both sides. So that 2 becomes positive. I'm going to factor out a negative 1. So that's x squared plus 4x equals 2. Then I want to complete the square. So I take half of 4 and raise it to the second power, which would be 4. Bring down my 2. So I have to add the equivalent. So 4 times negative 1 is negative 4. All right, factoring x plus 2. So I'm taking the square root here, perfect square trinomial, putting it in vertex form. So I have to bring down that 2. And 2 minus 4 is negative 2. One last piece here. We got negative 1 times x plus 2 squared. Since that 2 is negative, when I move it over, it's going to be a positive 2. So hopefully you can see it. So my vertex here is 2. We're actually negative 2 and positive 2. Right, but we don't want that maximum height. So we want the y value, which is 2. So the max value here equals 2. So that is actually going to be smaller. All right, and then the B part says the y-intercept of f of x is blank the y-intercept of g of x. So we could just look at the forms here. So y-intercept, this is standard form, ax squared plus bx plus c. Remember, c is that initial value or our y value. So for f of x, our y-intercept equals -2. The y-intercept here, so this graph is going by halves. And so when I first looked at the graph, I was like, okay, this is -2, right? But our value, this point is given. So we can see that this graph has decimals on it. And so my y-intercept here would be at -1. So make sure you're paying attention to your graph. So for g of x, the y-intercept is -1. So which one is, so the y-intercept of f of x is smaller than the y-intercept of g of x because -2 is smaller than -1. Let's take a look at number 9. It says, consider the parent function f of x equal x squared. Describe the transformation applied to the function. I find it easier to just look at the vertex. That helps me to make sure that I'm doing a correct transformation with my horizontal transformation. And so I have the vertex form over here. So of course on a test, you would just have to know that this is in vertex form. So remember your vertex is HK. And so my vertex here is 3, -2. It's going to always be your opposite because that original 3 would have to be a positive if you have a negative in your formula. So remember, inside the parentheses, H, horizontal, so left to right. So this is right 3 units. That is my horizontal transformation, which is my K, my H. And the vertical transformation is here, so that it would be down 2 units right here. So that's my transformation. Number 10, which of the following relates f of x to g of x? So f of x is the red graph and g of x is the blue graph. So it says relates f of x to g of x. So g of x, we're gonna see what happens from g of x to f of x. So that graph went up. Didn't go left or right, it went up. So that is a vertical transformation. So we could eliminate A and B because these are all horizontal transformations because they're inside parentheses. And so C and D will represent our vertical. But now we have to read the question carefully. It says relates f of x to g of x. And so from g of x to f of x, that graph goes up. So that's my K value is going to be a +6. And so C would be my answer for this transformation. Our last problem we're going to look at, it says f of x is x minus 4 and g of x is x squared minus 3x minus 4. Which are the values of the x solutions for when f of x equals g of x? So basically, so the solutions are where these two graphs cross. And so that would be here and here. So our ordered pair here, this is the ordered pair, 1, 2, 3, 4, 4, 0. Let me make my comma look better. So 4, 0. And this is the ordered pair, 0, -4. And so it says, what are the x values? So the x values here are 4 and 0. And so those are my answers here. It would be 0 and 4. And we're done. All right, we have reached the end of our review, and I would like to thank you for learning with me.